right, we're beginning the section 12.4 video. What's it about? I don't know because I forgot to put a title in. That was stupid. Here's what it's about. The essential question will tell us. So I'm looking to simplify rational expressions meaning fractions, that involve variables and possibly multiple terms. So here's your meme. I'll let you just savor that for a second. All right, moving on. Reminder. If you only have multiplication in your fraction, you can just start canceling right away. When fractions involve multiplication, we can do the same thing to the top and the bottom, and that involves dividing. So for example, if I have 8 over 10, I can divide the top and the bottom by 2 to get 4 over 5. So because of this, if there's multiplication, which is kind of like division, I really can cancel. However, if I have any addition doesn't work quite like this. Addition involves distribution, it could involve FOIL, it involves more complicated things, so you must factor first to generate the multiplication, then you can start canceling. So I'm just going to do 3 examples. The first one, let's analyze it. Which situation is it? Is it the multiplication situation or is it the addition situation? Well, clearly here everything is just being multiplied together. Multiply, 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 multiply. And this is the situation where I can just start canceling. So first of all, the 6 and the 8, I can treat this like a fraction because it is a fraction. 6 and 8 reduced to 3 over 4. How about the x squared and the x to the 4th? There are 2 x's on top and 4 x's on the bottom. So these 2 x's will cancel, leaving me with 2 on the bottom, right? Because if there are 2 x's on top and 4 on the bottom, these 2 cancel, these 2 are left on the bottom. We've done this before, right? Do you remember it? Here I have 3 y's, 1 on the bottom, so that'll leave me with 2 y's on top. One of the y's got canceled, and I was left with 2 on top. And this is my final answer. So this is a problem that we've done before. However, it got complicated in this section because we could have problems like this. Now, what many people are tempted to do is they're tempted to just start axing things. Okay, I can take off one of these x's. I can take off the 8 and the 12, leaving me with, what would it even be, 2 and 3. You can't just start doing this because the addition makes it more complicated. I can only cancel when I have multiplication, like in this problem. Thankfully, I know a way to create multiplication, and that is by factoring. So let's see how this guy factors. Since I only have 2 terms, I'm going to be looking to pull out a GCF. So let's see if we can figure out what the GCF is. What is the biggest thing that I can pull out of both of those terms? Well, that would be 2x. We've factored a lot with GCFs before, just not in a little while. I can pull out a 2x. That leaves me from this term, if I pull out a 2x, I'm left with just x. From this term, when I pull out a 2x, I'm left with 4. Okay? And I think the same thing is going to apply to the bottom. Here, definitely can't factor with like reverse FOIL, but I can do it with GCF. If I pull a 3 out, that leaves me with x from here, and then 4 from here. Now I can check my GCF factoring. If I distribute back in, do I get back to this? Well, yeah, I'd have 3x plus 12. If I distribute this back in, 2x squared plus 8x, oh look, that's what's on the top. So I know that this distribution is legit. Hey, do I see anything I can cancel? I have a 2 times an x plus 4. I have a 3 times an x plus 4. These x plus 4s will cancel, leaving me with just a 2x over 3. Pretty cool. And I could do it because I had multiplication. This was something that had been multiplying the rest of the stuff. And since it was identical on the top and the bottom, I could cancel it. We're going to just do one final example. This is a short video. Here, again, can't just start doing this. People will try to do this, and I will laugh at them because I'm telling you right now, don't do stuff like this. It's not how it works. If there's addition or subtraction anywhere in your fraction, you have to be more careful. You have to first factor before you do it. So don't just start canceling. Factor first. Now, each of these are very clearly reverse FOIL factoring. So in this section, if you're not good at reverse FOIL factoring yet, you're going to get good at it. On the top, it's going to be -3 and +2. Not sure why. Well, remember, this foils back to this. Like if I foiled out these parentheses that I've chosen, it would foil back to that. How did I choose these specific parentheses? Well, negative 5 times 2 is 10, and negative 5 plus 2 is negative 3. So let's do the same thing with the bottom. Here I'm also reverse foiling, and I think my numbers will be x plus 4 and x plus 2. You can prove to yourself that that foils back to the original, but we've done factoring so many times, I'll trust that you know how. So if you notice on the top, I have x minus 5. On the bottom, I have x plus 4. These two don't cancel, but the x plus 2, the x plus 2 and the x plus 2 do cancel. That leaves me with x minus 5 over x plus 4. Hey, can you cancel the x's? No, don't do it, because you will lose massive amounts of points. Since I have the addition and the subtraction, I cannot just go and cancel the x's. I would need to have multiplication to do that. All right, that's the video. Summary, don't cancel within addition. Don't do it. It will make you lose massive amounts of points, and you'll be very sorry.